All right. So we have the linear is a power of 1, area is a power of 2, and volume is a power of 3, right? And we said this was volume, so that's going to be in our volume category. 8 to 27. We take that cube root, and in order to do that cube root, just one more time, you go into your keyboard, you go into functions, into miscellaneous, and then n root right there, okay? So once we've done that, we've taken this 827 and made it in a 2 to 3. So 8 to 27 in volume turns into 2 to 3 in length, and it wants the ratio of the lengths. So this is going to be a 2, and this is going to be a 3. Anytime you go from volume to length, you just take the cube root. Anytime you go from area to length, you take the square root. Anytime you go back from length to area, you square it, and from length to volume, you would cube it. Okay, so it all boils down to what's the exponent for volume and what's the exponent for length. Does that kind of make sense? Maybe? Okay. Let's go back to question number 3. So proud of everybody who did this. This container is composed of a right cylinder and a right cone, and I want to know the surface area. So you need to think about 3 things. You want the top of the cone, which is the lateral area of the cone. And then you want the lateral area of the cylinder, because that's the sides of the cylinder, right? And then we want the circular base. So that bottom part is only one circle. So that's pi r squared, right? And then this one was LA of the cylinder. So then we need to go to our formula sheet. So if we go to the formula sheet, we've got lateral area of a cylinder, 2 pi RH, and lateral area for the cone, pi RL. Notice that the L is that slant height, right? So we need pi RL, and then pi RH. Okay, so if we come back over here, of the cone, that's pi RL, and then 2 pi RH. Then it's just a matter of substituting. So in my calculator, I'm going to do pi, and then the radius is 12, and the slant height is 13. And then we're going to do this one, 2 pi RH, 2 pi, the radius is 12, and the height is 10. And then for that bottom circle, pi, and then 12 squared. When you put all of that into the calculator, you get your answer. So 3.14 times 12 times 13. That first answer is 489.84. And then 2 times 3.14 times 12 times 10 is going to be 753. And then 3.14 times 12 squared, or 144, is 452. When you add all of those up, it's going to be more than 400. It's going to be more than 750. It's not going to be, well, I don't know which one it's going to be between those two. Anybody got an answer for me?
About
1696. And the trick here is to realize that that middle circle, this one right here, you don't need that. So you need the lateral area of those 2 solids and then 1 circular base, because you're just looking for the outside, not the inside, right? Questions on that, ladies and gentlemen? All right. Let's go look at our Schoology, because lots of people are missing things at this point, and it's making me sad. So the circles unit is finished. Your IXLs should be done. I'm going to grade those today. Your circle tests should be done. I have already looked at those. Some people started them, but then didn't finish them. So I don't quite know what that is all about. You do have these little mini practices for this week. So rectangular prisms and triangular prisms should be complete already. Cylinders and spheres are what we're going to do today, and then cones and pyramids are what we're going to do tomorrow. Compound shapes will be Thursday. We may get to the constructions, we may not, I'm not sure. And then the first 6 of our fellow classmates are going to take the SOL on Friday. Next week, we will be working on this quadratics notebook, and I'll talk more about that on Friday. If you are not here because you're taking the SOL, on Friday at some point, open up this quadratics notebook, okay? And that's going to be your task for Monday as well next week, next Monday, a week from yesterday. What I'd like to do now is if you would open up your surface area and volume folder and go to the rectangular and triangular prisms day. You've got some notes here from Friday. I'm pretty sure I posted a video. So there's a part 1 and a part 2 video because like today I had to stop it partway through. We reviewed these notes, but I didn't do a very good job on the triangular prism. So we're going to talk about those today. If you go hit next. Ooh, wait, I need to stop sharing. You will see the rectangular prisms, right? So the rectangular prisms practice, everyone who did it got 100%. The problem is a lot of people didn't do it. So I gave you time at the end of class. It wasn't very long, like maybe 5 or 10 minutes. But everybody should have done the rectangular prisms. Everyone who did it, like I said, got 100%. So I don't want to go over that one. I do want to go over the triangular prisms one because I did not do a very good job of teaching you that. So if you would open up that triangular prisms, that's what I want to talk about right now. And I'm going to need you guys to talk to me today, okay? So if you feel like unmuting yourself, that'd be fantastic. We're talking about triangular prisms. So that is this shape right here. And I don't know where my Screencastify went. It's hiding. This might be a 3. Maybe.